Hello, welcome to Hawk Math. Today we're going to be doing the 2015 AIME 1 problem number 10. And this problem reads, let f of x be a third-degree polynomial with real coefficients satisfying this equation. Absolute value of f of 1, f of 2, f of 3, f of 5, f of 6, and f of 7 equals 12. Find the absolute value of f of 0. Now, what do we know? Well, we know f of x is a third-degree polynomial. And a third-degree polynomial can only have 3 roots. But from this equation, we see that f of x is equal to 12 at 6 different points, the absolute value of f of x. Now, this means that 3 of these points must equal to negative 12, and the other 3 must equal to positive 12, because the cubic can only reach one y value 3 times. Now, for the rest of the video, I accidentally called f of x capital P of x for the animations, so please just regard these as the same function. We can write f of x in 2 different ways, either as ax cubed plus bx squared plus cx plus d, or the amplitude times the product of x minus each root individually. Now, the second form is probably more helpful since we know information about these 6 roots. So let's try to graph this. Here's my graph with 1 through 7 labeled. Now, we also know that certain points must lie on this function. For example, if the point 1, 12 is on the function, then we also know that by symmetry that 7, negative 12 has to be on the function. And because the roots, the only way to draw a cubic equation with roots, we must have that f of 2 and f of 3 are negative 12, and f of 5 and f of 6 are positive 12. We could have all of these signs be reversed, but if you notice the end of the problem, it says find the absolute value of f of 0, so it doesn't matter which method we actually choose. Here I labeled these points, and as you can see, this is the only way it really makes sense to draw on a cubic equation. Now, looking at this graph, we can easily tell that there are 3 roots. One of them has to be 4 because of symmetry. Now, the other 2 have to be equally spaced to the left and to the right of 4, again because of symmetry. One of these roots is between 1 and 2, and the other root is between 6 and 7. Let me move this graph so we have more room, and we can see that we can rewrite f of x as a times the root x minus 4 times the root x minus the quantity 4 minus b times x minus the quantity 4 plus b. Rewriting, we get this equation, and now we can plug in points we know, such as 1, 12 and 2, negative 12. This first point gives us this equation, which can be simplified down into a times negative 3 times negative 3 minus b times negative 3 plus b equals 12, or a times the quantity b squared minus 9 equals 4. The second point gives us this equation, which can be rewritten as a times negative 2 times negative 2 minus b times negative 2 plus b equals negative 12, or a times b squared minus 4 equals negative 6. Let me make more room by sliding these over here. And now we can see that if we divide these two equations, we get b squared minus 9 over b squared minus 4 equals negative 4, 6. And we can solve this for b to get b equals the square root of 7. Plugging this back into the equation, a times the quantity b squared minus 4 equals negative 6, we get that a equals negative 2. Therefore, we can rewrite f of x as negative 2 times the quantity x minus 4 times the quantity x minus 4 minus root 7 times the quantity x minus 4 plus root 7. The problem now asks us to find the absolute value of f of 0. So, plugging in 0, we see that f of x is equal to 72. But we want to find the absolute value of this, which is just 72. Now, the reason why we need to take the absolute value, as I previously mentioned, was because if we initially flipped the signs of all the roots, so that positive 12s became negative 12s and so on, our answer would have come out to be negative 72. Therefore, our final answer is 072, and we are done. Thank you for watching. I really hope you enjoyed this new style of video. Please let me know in the comments whether you like this or the whiteboard or me handwriting the problems better. And please like the video and subscribe if you want to see more.